Hello students, in this video I am going to explain about COD problems. This is the part 4 video of water chemistry module 4. And in COD problems there are three different types of problems which could come for the exams. So you have to use three different types of formulas to solve these COD problems. So the first problem is if normality of FAS is given. If normality of FAS is given, you need to use the formula V1 minus V2 into normality of more salt, that is N moles, into 8, which is the equivalent weight of oxygen, into 10 to the power 6, because you're measuring it in parts per million, divided by 1000 into V wastewater, that is volume of wastewater. The second formula is if normality of potassium dichromate is given. If normality of potassium dichromate is given, you have to use the formula COD is equal to V potassium dichromate, that is volume of potassium dichromate, into N potassium dichromate, that is normality of potassium dichromate, into 8 into 10 to the power 6 divided by 1000 into V wastewater, that is volume of wastewater. If they give molarity of potassium dichromate in the problem, then you need to use a slightly different formula, that is V potassium dichromate, that is volume of potassium dichromate, into molarity of potassium dichromate, into 8 into 6. We are multiplying into 6 because 1 molecule of potassium dichromate is equivalent to 6 oxygens. So that's why you have to multiply 8, that is equivalent weight of oxygen, into 6 because it is equivalent to 6. So you have to multiply it into 6 when you consider molarity, divided by 1000 into volume of wastewater. So this is the formula you need to use in case molarity comes. This is very important. You have to remember, if molarity comes, you have to multiply the same formula into 6. But if normality is given, because it's equivalent weights, you need not multiply it into 6. So let us see. I have solved three different types of problems in this video. So let us see first type of problem. So in the first type of problem, calculate the COD of effluent sample when 25 ml of effluent sample requires 8.5 ml into 0.001 normal potassium dichromate solution for complete oxidation. So please pay attention over here. They have given 0.001 normal potassium dichromate. So you have to use the formula in which normality of potassium dichromate is given. So you have to use the formula COD is equal to V potassium dichromate into normality of potassium dichromate into 8 into 10 to the power 6 divided by 1000 into V wastewater, volume of wastewater. So normality of potassium dichromate is 0.01. Volume of potassium dichromate is 8.5 ml, volume of wastewater is 25 ml, and equivalent weight of oxygen is 8. So substituting the values, we will get the answer 2.72 mg per liter or ppm. It's one and the same, mg per liter and ppm. The second type of problem, let us see over here. In the COD experiment, 25 ml of water was allowed to react with 25 ml of potassium dichromate solution. Potassium dichromate left over after oxidation of the impurities when titrated required 11.5 ml of 0.025 normal FAS solution. In a blank titration, 25 ml of potassium dichromate solution directly titrated required 18.5 ml of 0.025 normal FAS solution. Calculate the COD. So here, FAS solution normality has been given, and they have given you the blank titer value and back titer value. So the formula what we are going to use is V1, which is the blank titer value, minus V2, which is the back titer value, into N moles, that is normality of FAS or more salt solution, into 8, that is equivalent weight of oxygen, into 10 to the power 6, divided by 1000, into V of wastewater, that is volume of wastewater. So N more salt or normality of more salt is 0.025. Blank titer value V1 is 18.5, back titer value V2 is 11.5, V wastewater is 25 ml, equivalent weight of oxygen is 8. So substituting these values, we will get the answer for this problem as 56 mg per liter or ppm. The third type of problem, calculate the COD of the effluent sample when 25 ml of an effluent sample is requires 16.6 ml of 0.025 molar potassium dichromate solution. So remember over here the strength of potassium dichromate is given in molarity. So when molarity comes, we have to multiply it into 6. So use the formula COD is equal to V potassium dichromate into molarity of potassium dichromate into 8 into 6, because molarity is given, into 10 to the power 6 divided by 1000 into V wastewater. So M potassium dichromate or molarity of potassium dichromate is 0.02 molar, volume of potassium dichromate is 16.6 ml, volume of wastewater is 25 ml, and the weight of oxygen we need to multiply equivalent weight of oxygen 8 into 6 over here, because we are taking molarity. So substituting the values, we get the answer as 63.74 mg per liter. So this is the end of the explanation for the problems. Thank you.